when we talk about the formula writing, तो formula writing के अंदर हमें ये मालूम है कि different elements which belong to different group, because they have the certain fixed number of valence electron, तो उनकी valency means the combining power. There are two terminology, valence electrons you already know means the last shell electrons. They are last shell electrons. And I've just given you another terminology, that's valency. Valency means the combining power. How are they going to combine with other elements? Okay. So when we know about the group number, we know their valency, the valence electrons are going to be 1. Group 2, valence electrons are going to be 2. Then we have a transition metal. That's a totally different scenario. In the case of the transition metal, they show the variable valency, right? Their valency keep on changing. Now, what is the reason behind that? We have already studied in the periodic table. That's a chemical property of the transition metal, which make them different from group 1 and group 2, where they have the fixed valency. Here, the valency for the transition metals, that's their feature, which keeps on changing, right? Valency. Then comes the group 3 elements. The group 3 elements will be having the valence electron, that's 3. Group 4 will be having 4. Group 5 will be having 5 valence electron. 6 will be having 6. 7 will be having 7. And group 8 will be having either 2 in the case of helium, or they are going to have 8 in the rest of them. Okay? So these are the valency. Now, on the basis of the valency, now when they lose these valence electron, or when they acquire some extra electron in order to have a nearest noble gas configuration. So where is the noble gases? The group 8 are the noble gases. So all the elements, they admire the noble gases. These noble gases are the ideal gases जिनकी stability perfect होती है, ठीक है? उनके last shell valence electron perfect होते हैं. So all the elements, they want to be like noble gases. तो अब होगा क्या यहाँ पर? This is valency. अब होगा यहाँ पर कि ये जितने भी elements हैं, they want to acquire the noble gas configuration. जब ये acquire करेंगे noble, तो कुछ elements जो होंगे वो इलेक्ट्रॉन्स गेन करेंगे, कुछ लूज करेंगे. तो जिनके वैलेंस इलेक्ट्रॉन कम है वो लूज करेंगे, जिनके वैलेंस इलेक्ट्रॉन ज्यादा है वो गेन करेंगे. तो जितने भी मेटल्स होते हैं, अब इसका एक इलेक्ट्रॉन है वैलेंस इलेक्ट्रॉन, इट इज गोइंग टू लूज, इट इज गोइंग टू हैव पॉजिटिव चार्ज. ग्रुप 2 विल बी हैविंग पॉजिटिव 2 चार्ज बिकॉज इसके 2 वैलेंस इलेक्ट्रॉन है, वो आराम से 2 लूज कर लेगा. ग्रुप 3 will be has 3 valence electron, it will lose. So group 4 will be losing or gaining. Basically group 4 के जो elements हैं वो ions बहुत rarely बनाते हैं, वो ज़्यादातर sharing से compound form करते हैं. Group 5, in order to become a noble gas, it has got 3 short, so ये 3 electrons acquire करेगा. Group 6 will be acquiring 2 electrons, so the valency is going to -2. Group 7 will be acquiring 1, and they don't need any electron break because they have the maximum number of valence electron जो कि उस particular shell में होने चाहिए. तो formula writing के लिए कुछ elements तो हमें जो simple ions होते हैं, simple ions क्या होते हैं? Simple ions are the ions which are being formed by the elements. Like for example, lithium belongs to group 1. So lithium will always have a charge of positive. Sodium will always have a charge of 2 plus. Similarly, potassium will have, because these are group 1 element. तो इनकी जो valency है, इनका जो charge है, ठीक है, वो सारे group 1 element के ऊपर रहेगा. That will remain on all the group elements. ठीक है? Lithium, sodium, potassium, rubidium, cesium, they all will be having positive charge. Similarly, group 2 में calcium 2 plus, we have magnesium 2 plus, we have beryllium 2 plus, right? So all the group 2 elements will be having a positive 2 charge. All the group 3 elements will be having 3 positive charge. Boron 3 plus, aluminium 3 plus, and so on. Group 4, I told you, they do not form ions. They only form the compounds by sharing because वो midway हैं. They have the 4 valence electron. The ions बहुत rarely form. Group 5, like for example, we have nitrogen, we have phosphorus, so they will be having a charge of 3 negative, right? अच्छा, एक चीज और यहाँ पर बहुत interesting है. वो interesting चीज ये है कि जब भी आपके ये these are metals, group 1, group 2, group 3 transition metals, ये आपके metals हैं, ठीक है? और इनके बराबर में जो है on this side from group 4 onwards till group 8, these are basically your non-metals, ठीक है? तो जितने भी metals होते हैं, they form a cation, and the cations are what? They are positively charged ion. They're positive, they form the positive ion because they're losing their electrons. Whereas the non-metals, they will be forming an anions because they're gaining what? They're gaining the electrons. ठीक है? अब जो cations होते हैं, उनके नाम, we know the chart, we know the symbol, right? Their naming is very easy. Like for example, we will be calling it sodium ion, right? We'll be calling it potassium ion. सही है? We will be calling it this, we will be calling calcium ion. तो इनके नाम वही होते हैं जो इनके names of an element होते हैं, ठीक है? लेकिन जब हम anions की बात करते हैं, when you talk about the anions, तो anion के names के साथ suffixes लगे होते हैं. They have the suffixes added to them. और ये suffixes जो होते हैं, they are either "ide" or "ate" or "ite." ठीक है? जब आपके सिंपल, व्हेन यू हैव द सिंपल एनायंस क्या होते हैं? जब सिंगल एलिमेंट जो है, सिंगल एलिमेंट जब आपका एनायन फॉर्म कर रहा है, ठीक है, व्हेन सिंगल एलिमेंट आर फॉर्मिंग आयंस, राइट, नेगेटिवली चार्ज्ड आयंस, तो उनके ऊपर नॉर्मली दे हैव द सफिक्स व्हिच इज नोन एज आइड. ठीक है, they have a suffix "ide." Now for example, if I need to write down the name for this N3 negative, तो इसका जो नाम होगा, it will be known as, its name is going to be nitride. This is a simple, तो element जो है वो आपका, this is going to be known as nitride, right? Nitride. Simple ions, उनका suffix जो होगा वो "ide" होगा. Similarly, we will be having phosphide. ठीक है? अब O2 वाला जो है सॉरी ग्रुप 6 जो है, दैट इज गोइंग टू बी O2 नेगेटिव और S2 नेगेटिव, और इनके नेमिंग में भी ID लगेगा. सो दिस इज गोइंग टू बी ऑक्साइड एंड दिस इज गोइंग टू बी सल्फाइड. ठीक है? Similarly, you have the next category of group 7. So we have fluoride, we have chloride, bromide, and so on, right? So the simple ions, they have a suffix which is where you have an "ide" added to it, right? So they are easy to understand. So all these charges we know because we have studied the periodic table. We know the position of these elements, and we know their position in the periodic table to which group they belong. We know what are the valence electrons of these elements, whether they belong to group 1, group 3, and group 4. And accordingly, we know what is their valency, and we know the charges on these ions. Or simple ions, if you have a cations, there's no change in the name, no addition, no prefix, no suffix, okay? No suffix, nothing being added. You simply have the name of an element and you add ion to it. But when you have a simple anion, then what do is we add "ide" to it, right? And anions are the ones, they are the non-metal ions. This much is clear. So these we already know. Okay. Now comes the complex signs. So certain complex signs we have to memorize. How are these complex ions being formed? We don't have to study how they're being formed, but we have to memorize the complex ions, their formulas, and their charges. Formulas and the charges on them. So let's do the cations first, the list of cations first. The simple ions we have already done. Now we are doing the complex cation. So under the category of complex cation, we have only one present, that is basically your ammonium ion. And the charge on the ammonium ion is basically, the formula is NH4 positive, and the charge is basically positive. Okay, so this is a formula and this is a charge. So you need to remember the formula and the charge for ammonium, and this is the only one complex cation. But we have multiple complex anions, right? So let's start with the complex anions. So we have OH negative, and this is basically known as hydroxide ion. Similarly, we have CO3 2 negative. So this is known as carbonate ion, right? Then after this, we have SO4 2 negative. This will be known as sulfate ion. Then we have SO4 3 2 negative. We have sulfite ion. Then we have NO3 negative. This is known as nitrate ion. Then we have PO4 3 negative. Then that is known as phosphate ion. We have HCO3 negative. That is your hydrogen carbonate ion. Hydrogen carbonate ion. PO3 3 negative is known as phosphite ion. Okay, so these are some of the anions, the complex anions whose charges and the formulas you need to remember. Okay, now many a times students, they get confused between the ate ions, the ions, the anions which have a suffix ate, and the anions which have the suffix ide. Ide, I've already told you, Abhi, कि ides are the ones which are basically your simple anions, which are just formed of one element. And why are we calling them the complex anions? Because they are made up of more than one element. Here, the hydroxide is formed of oxygen and hydrogen together. The carbonate is formed of carbon and oxygen together. Sulfate is made up of sulfur and oxygen together. So that is why we are calling them the complex ions. The complex ions are the combination of combination of two or more elements. These are complex. So you have to memorize the formulas and you have to memorize the charges. Okay. Now coming, we were talking about the difference between ide, we already know, right? Now we need to know the difference between the ate and the ides. Now look here, I have one is my sulfate. This is my sulfate. And below that, I have a sulfide. So the easy way to remember the difference between a sulfate and a sulfide, look at the oxygen number. In sulfate, we have SO4. We have SO4, 2 negative. And in sulfite, we have 2 SO3, 2 negative. So sulfates or ates are the one with the maximum oxygen content in them. They have the maximum oxygen atoms present in them. Whereas the ides are the one with one oxygen atom less than eights. ठीक है? So अगर मैं sulfate कह रही हूँ तो sulfate is SO4 2 negative. So sulfites are going to be SO4 3 2 negative. The charge is the same. Similarly, I have another combination. I have phosphate, right? I have phosphate and I have phosphite, right? So if the phosphates are, if the phosphate is phosphate, if the phosphate is PO4 3 negative, then the phosphites will be having one oxygen less than phosphate. So they are going to be PO3 3 negative. Charges are same, right? Coming to the next combination, I have just written down one over here. I have written down the nitrates, right? So if my nitrate is NO3 negative, then what will be my nitrite? Now my nitrite will be one oxygen less than nitrate. It's going to be NO2 negative, the same charge negative. So they will be having the same charge, but only the oxygen atom will be one less than the eights, right?